Welcome to EDU World Space.
This question is giving you three complexes, shown here, and asks which of the three complexes are different types of isomers. So geometric, linkage, optical, or coordination sphere isomers. And for this question, you need to know what these types of isomers are. So we'll go through each one, and as we do, we'll identify which of the three compounds relates to each isomer. So a geometric isomer is an isomer that has the same chemical makeup, but the arrangement of the atoms are different. And so you could imagine for each of these, whether it's a metal with 6 things bound to it, or a metal with 4 things bound to it, you could switch out where these things are and it would create a different isomer. And so for the geometric isomer, with compound number 1, you could imagine these 4 NH3s around the center and the bromines on the top, or you could imagine where the bromines are right next to each other and then the amines are all across, and therefore 1 can have a geometric isomer. In the same way, complex 2 can also have geometric isomers. And again, in the same way, complex 3 can have a geometric isomer. A linkage isomer is where a particular ligand can bind to the metal in different ways. And for this ligand, for this type of isomer, you have to have a specific ligand that has multiple lone pair electrons. And for that, we're looking specifically at this ligand here, this ONO, where each of these oxygens could bind in a different way. And so the linkage isomer is ligand 2. Optical isomers are isomers that are chiral, so they have mirror images that cannot be superimposed. And this is specific to the type of ligands that you have and the arrangement of those ligands. And so for the optical isomer, our only candidate is number 3, where this ethylene diamine molecule is bound in a cross fashion. And so when you do a mirror image, those two molecules are no longer superimposable. And so our optical isomer is number 3. Coordination sphere isomer is an isomer that differs in which species in the complex acts as a ligand and which one is outside of the coordination sphere. And so for that, you have to have something outside of the coordination sphere. And of these 3, this number 1 has this chlorine that's outside of the coordination sphere. And because chlorine can also be a ligand in this complex, you could imagine the chlorine is in here, and either bromine or an NH3 is the outer outside of the complex. And so for that, number 1, I'll just put it below it. Number 1 is a coordination sphere isomer.